Okay. Good evening, student. Namaskaram. Today we are going to discuss stationary waves in open and closed pipe topic. This topic belongs to waves chapter. Okay, 12th physics waves chapter. Intermediate senior okay. So this is a important 8-mark question. Stationary waves in open and closed pipe. Okay, right. Okay, so first of all, I will show you presentation. Okay, right. Musical instruments like flute, clarinet, nadaswaram, etc. are known as wind instruments. Okay, wind instruments. They work on the principle of vibrations of air columns. You can see some of the musical instruments here. So these all the musical instruments work on the principle of vibrations of our air in that column. Okay. The simplest form of wind instrument is the organ pipe. It is made up of wooden or made up of metal pipe, which produces a musical sound. Okay. For example, you can see in your day-to life, there are many musical instruments, nadaswaram, clarinet, flute. Okay, they are the organ pipe instruments. Okay, right. So before we are going into that, what is mean by closed organ pipe? What is mean by open organ pipe? How the frequencies are formed in that separate area? You have to know what is standing waves or what is mean by stationary waves, because standing waves is also known as stationary wave. Standing or stationary means which is mean rest. Okay, appears to be rest in that position. Okay, so standing waves, also known as stationary waves, are a particular type of wave pattern that occurs when two waves of the same frequency and amplitude traveling in opposite direction within the same medium. Okay, within the same medium, one way travel to the right and another way travel to the left. They are superposed. Superpose means overlap, interact, interference. Okay, superpose. So then the waves are formed that called as stationary waves. So unlike traveling waves, which propagate through the medium, because traveling means travel, okay, which propagate through the medium, standing waves appear to oscillate in place. Okay, hence the term standing. The formation of standing waves involves a interference of two waves. Already I told you interference. Interference means mix or superimpose, lot of words there. Okay, right. So this is a simplest wave format. I will show you another file, how the stationary waves are formed. Okay, I will show the another file. You can see here. Okay, so here a blue wave that traveling on that left. Okay, left traveling wave is here blue. Okay, in here is blue. Blue is traveling towards left, and the green wave that is traveling to the right. So right traveling wave here green. Okay, first of all, just look at that two waves only, blue and green. One is towards left, another one is towards right. Okay, when these two waves superimpose or superpose or interference, there will be another wave formed or another wave created. That means standing waves. Here you can see red color wave. Okay. So here red means resultant wave, which is the addition of green wave plus blue wave. Okay, which is a interference of that two wave, blue wave and green wave. So red is the resultant wave, that called as stationary waves, also known as standing waves, because you can see in that diagram or in that picture, just red waves only vibrate in the same position. So it appears to be rest in that position. Okay, because you can see blue wave or green wave which is traveling towards one position, towards another position. Okay, right. So now you can just remember what is stationary wave, how it is formed. Okay, right. Okay. So here very important points according to that stationary wave or standing wave, because you have to know what are the characteristics of this standing wave or stationary wave. Okay, this wave does not move, it remains steady at its pace. Already you saw that red wave. Okay, that wave does not move, it remains steady at its pace. Certain points in the region in which the wave exists have maximum amplitude or minimum amplitude. That means zero amplitude. Suppose maximum amplitude means we have labeled it as antinode A. Okay. Suppose amplitude is zero or amplitude is minimum in that point or in that region, that point is called as nodes, labeled as N, capital N. Okay. Later we will write. Okay. So another one is very important point here. That is distance between two consecutive nodes or antinodes. So here lambda by 2 is converted into star. Okay. So which is one second, because lambda by 2 now you can see lambda by 2. Okay. So distance between two consecutive nodes or antinodes, which is lambda by 2. Lambda means wavelength, because you say that wave. So wave has fundamental property wavelength. So lambda by 2, which is a distance between two consecutive nodes or antinodes. Suppose we have to find what is the distance between a node and its next antinode, that called as lambda by 4. Okay. Note it down. The distance between node and next antinode is lambda by 2. Between two node or between two antinode, lambda by 2, which is a lambda is a wavelength. Okay, right. So here clarinet is a musical instrument. Clarinet is an example of a closed organ pipe. Okay, it is a example for closed organ pipe. And another one musical instrument is a fluid. Is an example of open organ pipe. We will go into that what is open organ pipe, how frequency is formed in the open organ pipe, how frequency is formed in closed organ pipe. Before we go into that topic, you have to note it down what is stationary wave and what is the characteristics of this stationary wave, how stationary waves are produced, and what is the exam for one very very simple exam for open organ pipe and one exam for closed organ pipe. Okay, right. So first of all, we will discussing closed organ pipe, clarinet. Okay, just remember that musical instrument, clarinet. In that example, you have seen that which is a tube, one end closed and one end open. Here open, here closed. Okay, you can interchange that, nothing problem. But in that closed organ pipe means one end open and another one end is closed. It is a pipe with one end closed and another end open. Suppose here we send one wave, it will reflected in that closed end and returns back with a 180-degree out of phase. Okay, one wave travels through this open end because here closed end, so wave cannot passing through this end. Okay, it will impact bombard in this closed end and reflected. So reflected wave, here reflected wave. So reflected wave is 180-degree out of phase with the incoming wave. So here incoming wave, here reflected wave. 180-degree means suppose one wave reflected in this position, reflected wave formed at here. So this is incoming wave, after reflected by this closed end, this wave is called reflected wave. This is a fundamental property of a wave interaction with that closed end. Okay, 180-degree out of phase with the incoming wave. So there is no displacement of the particle at the closed end. Here you can see waves are here. So there is no displacement. So there is no displacement means here nodes are formed. Already I show you that some points are maximum amplitude, some points are minimum amplitude or zero amplitude and nodes. So here no displacement. So that end is called node. So nodes are always formed at the closed end. Okay, right. So suppose, so this end node. Okay, what is the name of this end, sir? This is antinode. A. We can label it as A. A means antinode. Okay, right. So let us take tube. This is closed end. This is open end. L means length of the tube. Suppose waves are formed through this end and incoming wave after reflected goes here. So this end is labeled as node. This is antinode. Antinode means maximum displacement. Okay. So here particles have a maximum displacement. Here particle has a zero displacement, no displacement. So nodes are always formed at the closed end and antinodes always formed at the open end. Please remember that. Please note it down. So this is a very fundamental, basic, important points. Let us consider one simplest mode of vibration of the air column called the fundamental mode. So before we are going into the fundamental, we have to know what is fundamental node. Already you may familiar with a what is a stationary wave or what is fundamental mode. Yeah, okay. What is fundamental frequency? In the world of acoustic and sound production, the term fundamental frequency often comes up. Yeah. But what exactly does it mean? What is the meaning of fundamental frequency? In the context of sound, it represent frequency, represent number of vibrations or number of oscillation per second. Oh, this is a basic definition of for frequency. Okay. In the context of sound, what do you mean by frequency? That is, it represents the number of vibrations or number of oscillation per second. Hertz is a unit, which is frequency measured in hertz. Okay, right. When we talk about frequency in the world of physics and sound, it is essential to understand that it is a fundamental property. Okay, frequency is the fundamental property of that wave. So sound also one form of wave. Okay, so frequency is the fundamental property of that wave that influences various aspects of our auditory expressions. Okay, so frequency is nothing but number of vibration per second. Okay, so frequency can be talked of as a pitch. Okay, so frequency can be talked of as the pitch of a sound. Higher frequency means high pitch. Okay, higher frequency means high pitch, and lower frequency means low pitch. Okay, for instance, a high pitched whistle produces a sound waves with a high frequency. Okay, and maybe or deep bass note has a lower frequency. Okay, right. So frequency plays a important role in our sound production. It determines how we perceive the pitch and the tone of a sound. Different musical instruments and vocal cords produce sounds with a varying characteristics frequency, resulting in a unique tones. Okay, unique melody, like like that. Okay, right. So fundamental frequency often abbreviated as F naught. In some book, it is labeled as F naught. Fundamental frequency labeled as F naught. Okay. It refers to the lowest frequency. It is a simplest frequency, fundamental frequency that refers to lowest frequency produced by sound producing system, sound producing musical instruments. Okay. Suppose in future you may hear that one word that is fundamental frequency. Just remember that. Oh, okay. Fundamental frequency means which is the lowest frequency according to that sound producing system or sound producing musical instruments. Okay, which is the lowest frequency, low pitch. Okay, it is the most prominent component of that complex sound and forms a basis for the perceived pitch of the sound. In simple terms, it can be considered as the building block of sound. Okay, atom is the building block of matter. Okay, so here, what is the building block of sound? This is this fundamental frequency. For example, a vibrating guitar string produces a fundamental frequency that corresponds to the notes being played. You may seen that notes, right? Musical notes. So musical notes corresponding to the fundamental frequency. While fundamental frequency represent the lowest frequency, there are also higher frequencies present in that complex sound. Okay. These higher frequencies are known as harmonics. So, which is greater than the lowest frequency, that is fundamental frequency. Some other higher frequencies are also present there. That higher frequency is called harmonics. Harmonics are overtones. Okay. Please familiar with that some of the important keywords. What is fundamental frequency? What is harmonics? What is overtones? Okay. These are the higher frequency which is greater than the fundamental frequency of that musical instrument. Each harmonic has a frequency that is an integer multiple that a fundamental frequency. For example, second harmonic means 2 into fundamental frequency. Third harmonic means 3 into fundamental frequency. We will write later. Okay. So these harmonics contribute to the overall quality of the sound. Okay. Right. So here node, node, fundamental frequency. Maximum displacement, no displacement here. Okay. So what are the other points we will be discussing here? That wavelength. Okay. So first of all, we have to know length of that musical instrument. That means small l. You can put it capital L also. Okay. Let us consider a simplest of vibration of the air column called fundamental mode. And the node formed at the open end and the node at the closed end. L be the length of the tube. Lambda be the wavelength of this wave. Okay. For the fundamental mode of vibration, which is written as L is equal to lambda by 4. You can recall that the distance between handy node lambda by 4. Already I showed that. Yeah, the distance between handy node to node lambda by 4. So that only I am writing lambda, sorry, L is equal to lambda by 4. Because lambda by 4 is the distance between handy node to node. So L, which is equal to lambda by 4. So here I can label it lambda 1 because we will be writing lambda 2, lambda 3, etc. later. Okay. So lambda 1 means 4 goes here. So 4 into L. Lambda 1 means 4 into L. Lambda is the wavelength, which is this is wave. This is wavelength. One wavelength. One wavelength means one wave and another one wave. Okay. It forms as a one simplest wave which has a distance, which has a length lambda. Suppose you have only half lambda by 2. Okay. Because distance varies lambda by 2. Suppose you have only half lambda by 4. One antinode, one antinode means lambda by 4. So that only we can write lambda by 4 here. Okay, right. So whole length lambda, half length lambda by 2, and another one half length lambda by 4. Okay, lambda 1 is equal to 4 into N. Then frequency F or N, we can return as N or F, N1. The relation between frequency and wavelength, which is V by lambda. So N1 means lambda 1. V does not change. Here V means speed of wave. That means 3 into 10 power 8. Already you know that. Okay. V means speed of the wave. That is speed of the light. 3 into 10 power 8. Lambda may vary. Frequency may vary. But the speed of this wave or speed of light does not change. This is a constant value. 3 into 10 power 8. So already we have a lambda 1 value. That is 4L. We can put here 4L. So the frequency of that note Fn1, which is equal to B by lambda 1, 3 into 10 power 8 by 4L. This is a fundamental note. Okay. This is a fundamental note. Already I told you about the definition of a fundamental note. Here you can see that frequency of that fundamental note in that closed pipe. Okay. Right. The frequency is higher than this fundamental frequency can be produced by blowing air strongly at the open end. Such frequencies are called overtones. So we can blowing air strongly, and we have formed another some addition of antinodes or nodes there in the closed organ pipe. So here another one example. Antinode, node, but okay, only is okay. So here antinode, here node. zero displacement. Here also node, okay? Here antinode. Okay, right? This is node. So length of the tube as well as small l here. But in this diagram, we have some addition of mode. This figure shows the second mode of vibration, having two nodes and two antinodes. Here you can see one antinode, two antinode, one node, two nodes. So two nodes, two antinodes, which is called as second mode of vibration. So in this diagram, we have to write what is the wavelength. Yeah, already I told you that is lambda by 4 is the distance between one antinode to node. So lambda by 4 because node to antinode to node, lambda by 4. So we have 3 lambda by 4. We have 3 lambda by 4. So L means lambda by 4 plus lambda by 4 plus lambda by 4 because we have 3 lambda by 4 because of two antinodes, two nodes are there. Just add up 3 lambda by 4. 4 goes into that here. So 4L. So small l we can write as small l and lambda 2 here label as 2. Okay. So 3 lambda 2. 4L which is equal to 3 lambda 2 or L is equal to 3 lambda 2 by 4. Lambda 2 means 4 goes here and 3 downs here. Okay. So lambda 2 which is equal to 4L by 3. So frequency for this N2 which is equal to speed of that wave by lambda 2. Speed already I told you 3 into 10 power 8. Okay. Right. Lambda by 2 here is 4L by 3. So 3 goes into the here. So 3. Okay. So this is a N2 frequency 3B by 4L. Already we know that B by 4L means N1. So 3 into N1. So N2 means 3 into N1. That means N1 means fundamental frequency. You just multiply 3 into fundamental frequency, you got another one frequency. This is a harmonics. This is a overtone. We can call it as a first overtone because of after fundamental frequency we have a first overtone here. Okay, right. So here 3. So that 3 denotes as third harmonic. Okay, yeah, N2 is equal to 3 into N1, which is a first overtone after that fundamental frequency. Here you can see 3. 3 into N1, 3 into fundamental frequency, you got a new frequency that is third harmonic because 3 here. So you called it as a third harmonic. Another one type, just more antinodes or nodes there. Okay. So here antinode, node, antinode, node, node, node. Okay. Antinode, 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 antinode. So here you have 3 nodes, 3 antinodes. Yeah, correct. Which is a third mode of vibration, which is having 3 nodes and 3 antinodes. So lambda by 4, already you know that the distance between anode, antinode into node, lambda by 4, node into lambda by 4, antinode lambda by 4. So antinode into lambda n, lambda by 4, node into antinode, lambda by 4, and antinode into node, lambda by 4. So you got the 5 lambda by 4, which is the distance of length of the tube. Okay, L. So L means lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4, because 5 lambda by 4 is there. So we can label it as 3. L means 5 lambda 3 by 4. Lambda 3 means 4 goes here, 4 L by 5. Okay, this is a wavelength of that third mode of vibration. And the frequency, you got frequency N3, which is V by lambda 3. V lambda 3 means 4L by 5. So 5 goes here. So 5 V by 4L. Already I told you V by 4L means N1. So 5 into N1. Now you are familiar with that. What is overtone? What is the name of overtone? What is the name of frequency? So this is a second overtone after the first overtone. And N1 into 5, which is gives N3. So this is a fifth harmonic. So in our closed organ pipe, we have only add number of harmonics. Okay. So we can written as 1, 3, 5 goes like that. So N1 is to N2 is to N3 means N1 is a fundamental, that means 1. N2 is the 3 times the fundamental, so 3 here. N3 means 5 times the fundamental, 5. So goes like that, which is a frequency of harmonics in the closed organ pipe. Okay, clear? Right. Now we are going to that open organ pipe. Open organ pipe. Fluid is a example of open organ pipe. Okay. So in open organ pipe means both side open. There is no closed end either side. Okay. Both side open. So air molecules here vibrate freely because there is no closed end. So suppose waves are formed, it will goes there. Okay. So it is a pipe with both ends opened. At both end open, at both open ends, antinodes are formed. Already I told you, antinodes are formed at open end. So here two open end. So here antinodes are formed. So here, here, here. There is no node, but inside the or middle inside that pipe, we can get nodes. Okay, right. So antinodes are formed at the open end. Let us consider simplest mode of vibration of the air column called fundamental mode. Since antinodes formed at the open end, a node is formed at the midpoint here because waves goes like that. and waves like that. So here you can see zero displacement. That means node. Okay. Node is formed at the midpoint of the pipe. L be the length of the tube, as well as already we know that what is L. L means length of that tube, this tube. Here we have two antinodes, one node. What is the distance? Let us think about it, because we know that the distance between antinode to node lambda by 4, and here node to antinode lambda by 4. So L means lambda by 4 plus lambda by 4. Okay, lambda by 4 means lambda by 2. We can label it as 1. Okay, this is a first wavelength, that is fundamental wavelength. So we can label it as 1. Lambda 1 by 2, which is equal to length of the tube, which is fit into that tube. Okay, that wave has a wavelength lambda, but here you have a half, like only half wavelength. So lambda 1 by 2 is a distance between two ends, that is called as length of the tube. Lambda is equal to L is equal to lambda 1 by 2. So lambda 1 means 2 into L. So frequency means N1. Already we know that relation between frequency and wavelength. Just divide the speed of wave or speed of light. So lambda 1. Yeah. Already we have a lambda 1 value. So put it here. So 2L. V by 2L, which is a N1, which is called as fundamental node. You got the fundamental node in a open organ pipe, which is which has a frequency N1 is equal to V by 2L. Frequency is higher than this fundamental frequency can be produced by blowing air strongly at the one end of the open ends. Such frequency are called overtones. Already we know that. Yeah, right. So in our next example, we have some addition of nodes and antinodes. Sorry. Okay. So this is the second example. So here antinode, no antinode, node, antinode. Antinode means maximum displacement. Nodes mean minimum displacement or zero displacement. So nodes, antinodes. This is a second mode of vibration in the open organ pipe, which is produced by blowing air strongly at the open end. Okay, you can blow the air strongly at the one of that end, open end. You can create the second mode of or third mode of vibration. But here another one example, second mode of vibration. We have a 3 antinodes and 2 nodes here. Okay. So what is the distance between nodes and antinodes? So here lambda by 4. So here lambda by 4. So here lambda by 4 and here lambda by 4. Okay. We have a 4 lambda by 4. So L means lambda by 4, lambda by 4, lambda by 4, lambda by 4. We can label it as 2. Okay. 2. 1 by 4, 1 by 4, 1 by 4, 1 by 4, which is gives whole 1. Yeah. So lambda 2. We got the L. L means length of that tube, which is equal to lambda 2. Lambda 2 means just label different from previous wavelength, but generally lambda is a wavelength of this wave. Okay, so L is equal to lambda 2. Lambda 2 means L, and frequency F2, sorry, N2. N2 means V by lambda 2. B by lambda 2 means L. So we got a frequency B by L. Okay, right. But just divide and multiple 2. 2 into V by 2L, which is same as V by L. Because already we know that V by 2L, what is called V by 2L? Fundamental node. That is called N1. So 2 into N1. N2, which is equal to 2 into N1, that is called first overtone. Since N2 is here, this is called second harmonic in the open organ pipe. So second, 2 is present there, second harmonic. This is the first overtone. Okay. So another one example for open organ pipe. So this is a length. You can label it as a lambda A, N, A, N, N, A, A, A. 3 nodes and 4 antinodes. So lambda by 4, lambda by 4, lambda by 4, okay, goes like that. So you can work it later. L is equal to 3 by 2 lambda 3. So lambda 3 means 2 into L by 3. So here also you can find frequency N3, which is equal to V by lambda 3. V by lambda 3 means 2L by 3. So 3 goes here. So V by 2L means fundamental node. So 3 into N1. So N3 means 3 into N1. So this is a second overtone and you got a third harmonic. Okay, because 3 is there. So in our open organ pipe, the frequency ranges or frequency of the harmonic in the ratio like that, N1 is to N2 is to N3 goes like that, which is equal to 1 is to 2 is to 3 is to 4 is to goes like that. Okay, because we have already worked on that. N1 is equal to V by 2L, N2 is equal to 2 into N1, N3 is equal to 3 into N1. So ratio is there. Okay, so this is a frequency formed in that open organ pipe. We will be discussing in one simulation. Wait, I will share you. So you can see one simulation here. One second. I will hide the video panel. Okay, okay. So, right. So here you can see that one simulation. In this simulation, we will be discussing stationary wave formed by sound. Sound waves are longitudinal in nature. Already you may know that. and formed enclosed in an open pipe, open tube. You can see the tube with that left end closed and right end open. Okay, here. Okay, this is the closed tube. That means one side open, one side closed. This is a closed tube. Imagine there is a speaker, like sound waves are formed at open end. So sound waves traveling to that tube and impact or bombard in that closed end and reflected. Okay, right. So there will be a stationary wave formed in that tube of particular frequency or particular pitch, which travel into the tube. These waves reflected and in that closed end. Okay, right. So one incoming wave, another one is reflected wave. Both are superposed and formed at the stationary wave. Okay. So here you can see blue circles. Yeah, which is represent the air molecules. Air molecules oscillating in that closed tube. What we are seeing here is a stationary wave pattern. If you look at the left end of the tube, you will notice that blue circles are not moving. Yeah, please look at it in the left end. That means closed end. Blue circles are not moving. Yeah, okay. Meaning that left end is the position of the node. Yeah, we can recall that node. Node means no displacement. No displacement means there is no displacement of air molecules in that place. Okay, ma? Right. Remember, node is the point on a stationary wave of zero displacement at all times. Here down you can see also displacement graph. N means node, A means antinode. Antinodes formed always at the open end. Nodes are always formed at the closed end. And in terms of displacement, there is no displacement means nodes are formed there. Some displacement is our maximum displacement there is antinode is there. Okay, right, right. So notice that N here and A there. Suppose this is a fundamental mode in a closed organ pipe. Suppose we can go into that second harmonic, third harmonic. Okay, right. First of all, you can just see that length of the tube below here, 1 meter. Vibration mode, fundamental. Length of the tube, 1 meter. What is the form of closed pipe? L is equal to 1 meter. Lambda means 4 into L, which is the formula for closed pipe. So 4 into L means 4 into 1, 4. So you got wavelength 4 meter. Yeah, correct. This is a fundamental. So we can go into the higher mode. That is first overtone. You can see here two antinode, two nodes present there. So here formula of length L. L means 3 lambda 2 by 4 or lambda 2. Lambda 2 means 4L by 3. Yeah, correct. 4L by 3. So L means here 1 meter. So 4 into 1 by 3. 4 into 1 by 3. So 4 by 3. 4 by 3 means 1.33 meter. So that only you got the here wavelength is 1.33. You don't see frequency because it is some mistakes in that Hertz value. Only see that wavelength and length. Length of the tube 1 meter, wavelength is 1.33. How it is formed is by this calculation, lambda 2. Okay, right. So lambda 3. lambda 3 means which is a second overtone, that is fifth harmonic in the closed organ pipe. So lambda 3 means 4L by 5. We got that formula. Already we got the equations or formula. 4L by 3, 4L by 5. 4 into 1 by 5, 4 by 5. 4 by 5 means 0.8 meter. We can check it. Second overtone. This is a second overtone. Notes are adding and antinodes are adding. This is the second overtone. Vibration mode is the second overtone. Length of the tube 1 meter. Wavelength is 0.800 meter. Correct. Right? These are all belongs to the closed organ pipe. Let us discuss about the open organ pipe. Okay. Both ends are open. So first of all, we can start with the fundamental. Open organ pipe. Okay. So one nodes and two antinodes are present. L means lambda 1 by 2. Lambda 1 by lambda 1, which is equal to 2 into L in a open organ pipe. 2 into L. This is a fundamental mode. Okay. Lambda is 2. Yeah. Here, here, length of the tube 1 meter. So 2 into 1, 2. So lambda 1 is 2 meter. This is a fundamental. And we can go to the next mode of vibration. That is first overtone. First overtone, you got that 3 antinodes and 2 notes are there. Yeah, correct? Right. Right. So this is a fundamental, first overtone. And you got the second harmonic, because already we know that L means lambda 2. Lambda 2 means L frequency. In terms of frequency, we have a 2 into NO. So that is called as second harmonic. Okay. So here in that open organ pipe, second harmonic, lambda 2 is equal to, which is equal to length of the tube. So length 1 means lambda 2 also. Okay. Also wavelength 1 meter. So you can see length of the tube 1 meter, wavelength also 1 meter. This is the first overtone. We can go into the second overtone. Okay. Here you can see how many antinodes or how many nodes are there. Nodes, 3 nodes are there. 4 antinodes are there. And lambda 3, L is equal to 3 by 2 lambda 3. So lambda 3 means 2 into L into by 3. Okay. 2 into L into by 3. Which is a second overtone and frequency. Okay. Which is a second overtone or third harmonic. Lambda 3 is equal to 2L by 3. L here 1 meter. So 2 into 1 by 3. 2 into 1 by 3. That is called as 2 by 3. 2 by 3 means 0.666 goes like that. Okay. We can round it off 0.67 or 667. Okay. So you can also have that in that below value. Length of the tube 1 meter, wavelength is 0.667 meter. Okay. So this is a open organ pipe, and already we can discuss about the closed organ pipe. These are all the topics today we got discussing. Okay, right. So if you have any doubt, please chat me, message me. Okay. Please be recall that what is stationary wave, what is open organ pipe, what is closed organ pipe, what is first overtone, second harmonic, first harmonic. Already I told you all the fundamental principles. Okay, right? Lambda means wavelength, L means length of the tube, N means frequency, V means that is sound. Okay, that is speed of the sound. Okay, like that. Any doubts? No doubt. Okay, we can finish that today class. Jai Vidyashakti, Jai Bharat, Jai Hind. Thank you.